Hello everybody, thank you for joining me once again. Root Beer here with question number 20 on the 2005 Pascal paper. Harry the hamster is put in a maze. He starts at point S. The paths are such that Harry can move forward only in the direction of the arrows. And that's an interesting looking maze. At any junction, he is equally likely to choose any of the forward paths. What is the probability that Harry ends up at B? Okay. Well, I'm going to draw this little maze thing here. We'll draw it front and center. And it splits off into threes, doesn't it? I don't think I'm going to draw the whole maze. I think I'll just draw sort of a representation of it. So we start at S. And then we branch. We got three different branches we can go through. What else happens? Then we've got a split part here, and that leads to A. And we go down here. We split into three again. And then that gives us D, C, and then the big one, B. So I feel like I did a question like this already. Was it this contest? We were working with paths. It was the 2005. No, man, I'm thinking of another question, but this is something I've seen a lot. So it brings me in mind of sort of an old taxi cab problem. There's a bunch of these. Like there's one that we sort of write Elvis. This is a very common sort of thing. So we sort of write Elvis, and I'm not going to explain this one right now. Because I feel like just introducing the problem is going to be a bit of an issue. But what we end up doing here is we basically label the now, guys, I guess what I'm thinking of is number of ways to get somewhere, and this isn't quite it, because we're labeling probabilities. What we've got here is sort of an elaborate probability tree. So when we get to this junction right here, we have three paths we can go through. And since each is equally likely, we get a probability of 1/3. At, we'll change colors again. At this split right here, we got two ways we can go through these paths. And at this orange split over here, there's three paths. Each is equally likely. Okay. Now, the way the probability works in a probability tree is you multiply along the path you've taken. So to get to A, we have a 1/3 chance to go down this pipe, and then a 1/3 chance for Harry to go down this pipe. Okay. So the probability of getting to A is 1/3 times 1/2. And we can work out these other probabilities. The B is the hardest one. So we'll leave B for a moment. Probability of C is you have to take 1/3 to get this path, and then 1/3 to get down here. We get 1/9, just like A is 1/6. And the probability of getting to D is 1/3 times 1/3 equal to 1/9. Now, Harry the hamster exits one of these pipes eventually. And if you know anything about probability, you'll know that the probability that something happens is always 1. And the probability of individual outcomes then add up to 1. So we could figure out the probability of B is just 1, the total, minus the probability of A, minus the probability of B, minus the probability of C. Okay, so we get 1 minus a 6th minus a 9th minus a 9th. That's one way to do it. It's just a quick calculation with fractions, but I'm not going to do it. I'm going to do it sort of the way I was hinting at. You sort of count paths. Now, to get to B, we have to hit this green node. So how can we get to this green node? Well, there's three ways into the node. What's the probability that we first went to the left and then came down here? Well, As I said, we multiply along branches. So we got 3 ways coming into this green node, and then we go down to B. Now they're independent of one another. So this way is 1/2 times 1/3. So there's 1/6 of a chance that we're going to come to B by going this way. There's just 1/3 of a chance that we go down the center pipe to start off with. And then coming down from this path, we've got 1/3 times 1/3. Now the probability that we get to this node, well, it's this pipe or this pipe or this pipe. And when you have ORs, you add them up. So we get 1/6 plus 1/3 plus 1 times 3, 1/3 times 1/3, which is 1/9. And this should give us the probability of B. Okay. And so again, this is another basic fraction that we can do. 1/3 plus 1/6 is 1/2. 1/2 plus 1/9, so that's 9/18 plus 2/18, so 11/18 we should have for the probability of B. Okay? But as I was trying to say, there are nice little problems out there where you follow a series of paths and they slowly come back in together. And the way you count up how you get to a certain, and you can only sort of go down certain way in certain directions. The way you get to a particular node is you count up the number of ways you could get to the previous nodes, the nodes that lead into it, and you add them up. And that's sort of what we're doing here with this probability. And there are lots of these. I probably did one on the 2004 or something because it's very familiar. It's something that if this is the first time seeing this, get used to it because it does happen a fair bit. I'm not going to say once every contest. I'm not going to say once a year in terms of contest, but it is a fairly common concept. So 11/18, let's actually see, is that possibly the right answer, or did I make an arithmetic mistake somewhere? So 11/18, there it is, it's C. Okay. Just clean up the 11 a little bit. But that's question 20, and we are done part B now. So let's get ready for question number 21. It would get its own sheet, even if we hadn't just filled up the sheet for question 20, because the part C questions are usually the harder, the more challenging questions on the contest. I wonder what's going to go on with 25, but so they usually require a little more attention. So I do caution you, if it's your first time writing, don't expect to even get close to the part C questions. And don't feel bad if you don't. They're for the really, really good people. Okay, you might become one someday if you keep practicing. But don't feel like you have to get the whole contest all done perfectly the first time. Okay, you might be a 100% student in class, but math contests require a little bit more, and they're a little outside the curriculum. That's why they're a contest instead of a nationwide standardized test. Anyway, excuse me. We'll join me for question 21 in the next video. Thanks for watching.